Hi, I'm Manjarres. I'm the lead FX instructor at Campus VFX, and this video is for those who are interested in joining us to learn Houdini, and it's about what would be very beneficial for you to already know before joining us. So the first thing that would be beneficial for you to already know is to be comfortable with vectors. What's a vector and vector manipulation, how you get vectors from different points. The second thing would be the dot product. What's a dot product? Because it's used a lot in FX. Third one would be cross product. And finally, what would be very beneficial for you is to have some very basic knowledge of coding, of programming. It will make it much easier for you if you already know some basic things like variables and functions, or at least what they are, how code flows. You don't have to know a very specific language, you don't have to be proficient in any of them, as long as you understand the logic of how a code flows. If you don't know any at all, it would be good if you want to have a head start to look into the SideFX VEX tutorial. So you can simply search SideFX VEX tutorial, and it's the first result, and you have some things that you can learn. You can just look at the maybe the 4 or 5 first chapters, six first chapters, and then they get into more the use of it and the functions, and that we can see at the school in class, but at least this explains the basics of programming. If you already know all these and you're comfortable with them, then you can just stop watching. That's all there is for you. If not, then stay here. I'm going to explain to you right now what vectors are, dot products and cross products. So what's a vector? A vector is defined by two things: its direction and its length. It's used in CG, for example, to define the position of points. So for this to work, we need the origin, we need a point of reference, and that will be our 0. And then any point is going to be defined by its coordinates, which are here on the x-axis and here on the y-axis. We are in a 3D package, which means we actually have a third axis, which is z, but I'm going to simplify here because it's the same thing 2 or 3 dimensions. There is not much difference. So A here is characterized by its x component and its y component. And to know what the coordinates are of this point, we simply need to count. So we have 0, 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here I put it in 1. And the y coordinate will be 0.5, 6, 7. You just have to count. So what about another point that I'm going to put here? How do I get the vector between A and B? B here is characterized by its x and y coordinate. I'm not going to count, it's 0.5 here and a 1.1, okay? I'm just gonna call them x and y. How do I get the vector A, B? Well, to get a vector, we simply need to subtract the coordinates of one point to the other. If I want to get the vector that goes from A to B, the vector AB is going to be B minus A. So think of it as a bow and arrow. I'm going to start from the target, pull back, I'm going to do B minus A, and to get the direction, it's just when I release, where does it go? So here it's going to go from B minus A, pull, pull, pull. If you release, it's going to go this way. So AB, obviously not that long, it's going to be, the length of it is going to be the distance between those 2 points. Speaking of length, how do I get the length of this vector? Well, It's very simple, although we don't need to do that this way in Houdini, but it's simply a Pythagoras theorem where we have A, B, and C. Well, the distance is C, which means you have C squared equals A squared plus B squared. So C equals square root of A plus B squared. Don't worry about that, we don't have to do that actually in Houdini. We have functions and tools that give us the distance or the length, it's the same thing really. So don't worry about the actual math behind it, but just you'll have to understand how you get a vector from 2 points, A and B. Is going to be, if I want the vector BA, I will get A minus B. If I want the vector AB, I will do B minus A. So let's talk about the dot product. Let's pretend I have two vectors that are normalized. What does normalized mean? It means the length of the vector is 1. Doesn't matter where it points, as long as from here to here there is 1. So I have this vector here, and then I have this vector here. The dot product is the projection of one vector to another. So if you take this vector here, if you just extend it, then you project this vector onto it, the dot product is going to correspond to this length here. So think of it as 0 here, 1 here, and -1 here. To really understand this, it helps if you also know trigonometry. So if we get the trigonometric circle, let's pretend this is a circle, this is going to be between 0 and -1, so the sign here is negative. If I have two vectors that are both normalized and both going in the same direction, then the dot product is projection of this here. It's going to be 1 because they are aligned and they are the same length, so the dot product is going to be 1. If, however, it goes the other way, then the projection here is going to be here -1. And so basically the dot product of two normalized vectors simply gives you how much they are aligned or perpendicular. If I have a vector perpendicular to A, then the projection here is going to be 0. So that gives you basically something that is going to be between 1 and -1. That can be used for a lot of things, but we'll get into that when we actually start the class. So understand this. If you don't understand here this way, obviously you can't ask me the question because it's a video, unlike in class. Then I recommend just looking up dot product. There are a ton of explanations online. All right, let's go into cross products. Cross products are the cross product is between two vectors, kind of like the dot product, but unlike the dot product, which is the projection of a vector onto another and so returns just a float, a number, the cross product returns the vector that is both perpendicular to one vector and the other. Doesn't matter if those two are perpendicular or not, it will return the vector perpendicular to both of them. So it's that simple. So I never remember what direction matters. If it's the projection of the cross product of this one and this one return a vector this way or the other way. Doesn't matter too much. Like I said earlier, we're not doing math per se, we're just using the tools. So if you're doing something and you need the cross product, and you see your result is wrong, is pointing the other way, then just reverse the order or put a minus sign in front of it, and the problem is solved. So yeah, it would be good for you to already know all this, to be comfortable with them. Don't hesitate to look up more information or to experiment yourself in Houdini. But yeah, we don't need the actual math, we just need to know how they work and how to use them. And that we will see in the class, but it will make it faster for you to understand if you already know these basic concepts. So this was a fairly short video covering the most basic mathematical concepts that we use absolutely all the time in Houdini. If you come from a background that is more literature, art than science, and you got really scared by this, then don't worry about it. You can still do multiplication, additions, subtraction, divisions, and that's really all we need to learn these new concepts. So trust yourself, look things up if you need to, keep going at it, and you'll be fine. Bye!